Hello everyone, and welcome to the series of tutorials for Overlap2D Runtime. Let's open up our editor first. In this tutorial I'm going to get in depth on how to load a scene, on how to load your assets, load everything. So this is pretty much a coding tutorial, and we're going to code a lot and hopefully answer many of your questions. I prepared a little demo project for this. It's a small one, just a trees, sheep, house, and some particle effects, sprite animations, and images. And the point is to get this into your game. We're going to start with just a simple project, empty project, and what you need to do is to go to libgdx.logicgames.com and click on download, and then download setup application and keep it. And this is the third time I'm downloading that application. Yep, let's run it. You probably have tried this before, but let's just go through this thing. This thing requires you to give an SDK location path. Hopefully you do have an Android SDK for your Android projects. Well, you don't need one, I guess, if you're not using Android. So let's go to work SDK somewhere here. This is my SDK path, and this is a runtime demo folder that I created specially for you, and we're going to call the game a runtime demo, and runtime demo again, and then underwater demo, runtime demo. I'm not going to want an HTML and iOS project for this one. Android and desktop are just fine, and generate it. So here you can see this thing is downloading libgdx latest version and making your project. And what we're going to do next is to import it with our Eclipse. Obviously this can be done if you're using different IDE, but Eclipse is easy. Let's import a Gradle project. Browse here. It's in runtime demo 2. We click on build model, and it should build everything and get it ready for you to change. This is a standard empty libgdx project. It consists of several projects: the Android project, the core project, and the desktop project. The core project is your main logic, and Android is your launcher for Android phones, and desktop is your launcher for desktop. Is this done? Yes, I can close it now. So let's run it as a Java application, the desktop project. We choose this one, and you can see it's working. It's ugly and terrible. Let's go here. You can see the assets are in Android project, and what we're gonna do is open the main class and the launcher for desktop. I'm going to add some sizes to this because we want our window to be a particular size, because our demo project here is done for that size. It's 800 and this is for small outdated phones. Besides that, I am not sure why the background is red. Let's change it to black, run this thing, and yay, we have an empty, well, not empty, soon to be empty window. Let's delete this little guy, and now it's empty. So our goal is to bring these there, and the way we do it is first we export every asset we have here. Go to export settings, and well, we want to export that to our assets folder. Our assets folder is, I'm going to just put everything there without any particular very smart structure, and that's the easy way to do it. And so you can see it asks for where should it export the data files and the atlas packs and particle effects, maybe animations, stuff like that. I want everything in one place. You can do it differently. And we just save our settings, and when we click export, or Ctrl E in this case, and then we refresh the assets folder, and yay, everything we need is here. And everything we need is basically spine animations, which is empty, our original resolution pack for images, our particle effects images are here, but those are the particle data, our scenes, which is main scene data file, and main scene data file describes this particular scene. And then there is sprite animations. We have just one sprite animation, and it's ship, as you can see, and inside ship we have a texture atlas for the ship animations. Now our job is to first make sure we load that all. Well, first of all, before we do that, we need to include Overlap2D Runtime. And to do that, you can go to overlap2d.com and click on this link, which is open source LibGDX Runtime on GitHub. And then you click on download zip or clone it or whatever is best for you. I already did it, and I have it open here. I'm going to right click on our core project, go to Java build path, and add it as a project so we can use it. Now we're going to start with the most important class, which is a scene loader. Scene loader loads scenes, well, obviously. Scene loader equals new scene loader, and as you can see, scene loader requires essentials. Essentials is a kind of a container for us to have all the stuff that scene loader might need. You'll learn about this a bit later. Let's make this thing. Let's create essentials. E equals new. Equals new essentials. And let's get inside. These are some stuff that we're not going to use in this tutorial. There is a ray handler. So basically, scene loader would like to use the ray handler to render lights. And there is a skeleton render, which is required to render spine animations. We're not going to use any of those. We just need the iResource interface here. The iResource interface is something that you should implement to create your asset management class. And when you do, you can load everything from this folder and then provide a functionality for scene loader to get those. Let me show you how. Let's create a class that is going to be in core, and we're going to call it asset manager. Okay, and asset manager should implement iResource. And now we're going to add some unimplemented methods. And we're going to add a constructor and load assets. You can see that those are the functions that Overlap2D Runtime might need. It would need you to provide the atlas, main atlas file, texture atlas class, and then get an asset by name, and stuff like that. So we're going to go through this one by one. First of all, we're going to create the asset manager here, asset manager, and we're going to give it to essentials. Yep, this is a lot better. this is it. So we want our asset manager to load all the stuff we want to load. It's up to you how you do this thing. Basically, while it looks complicated, it gives you a freedom to decide how you load files, where you load files, stuff like that. You want to do it in different thread, it's up to you. But the point is, you implement the iResource, and then the scene loader will have a way of asking you to provide things you already loaded. Now, first of all, let's load our original texture pack, right? So private texture atlas, I don't know, assets, and then assets is equals new texture atlas. It gets the file handle, so we're going to load it immediately. It's GDX files internal, and then it's internal just goes to assets folder, so we should write original resolution / pack atlas. And that's it for loading our images. We can now proceed to getting this here. So get atlas function is done, and then get particular asset can be done by find region, and like this. So boom, this is done. We are not going to use skins, we're not going to load a project VO file, and we are going to use particles. So let's proceed further. We need a list of particles to be loaded. So the best way to do is to use hash map, particle name as a k, particle effect name, I'm sorry, and then particle effect here. So particle effects equals new empty hash map, and then particle effects. Let's just we have several particle effects. We use just firefly and rain in this demo, and I'm not going to get into listing this folder, or there are many ways you can see how many particles you have and load them all, but we're going to just load once by hand and a bit hard code it maybe. So it's going to be particle effect rain equals new particle effect, and then rain load and GDX files and particles rain, and it's just going to take the let's call it main pack. I like this. I want to do it like this. Those are the images for your particle effects, right? And this is not necessary. And then we say put rain. The other one is firefly. So firefly here, and boom, 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 boom. Seriously, I could put this into a different function, but I guess it's a job for you. Now that we have, now that we have particle effects here, so get particle, that's easy. Like this is a hash map, and we're going to do it like this. How about get all of them? It's going to be values, and how about we add cast? Yay! And this should be done in a skeletal atlas. We're not going to use that, and we're not going to use that. We need just the sprite animations. Our sprite animations are here. Let's load them. It's going to be another hash map. So those are texture atlases. Like this. Animations. And we're going to use our only animation, which is ship. We're going to call it ship, and then it's going to be new texture atlas, and so it's sprite animations ship atlas. Yay, we have our animations. I'm going to get them by name, and this this interface might change a little bit, I think, in future, but this is what you have right now. So basically this is it. If we run this, it should show nothing, but if it doesn't give any errors, it's probably good because we have everything loaded and ready to go. The other thing I forgot to say is that we need to load our scene. What our scene is the description of where the stuff is on your scene, like where the trees are, and you know, when you change this, it changes position, and it goes to main scene data file. It's a JSON file. It contains stuff like positions and layers, whatever. I think we're going to have a page on our website that will explain this in depth. But for now, what we need to do is to load it. So you say load scene, and it's another file handle. So GDX, sorry, files, internal scenes main data, and we have it loaded. Now we would love to display that, right? But to display anything that scene loader provides, you need the stage, because scene loader provides you with actors, and actors are loaded on LibGDX stage. I would love to find another way to do it. Maybe we'll change this, because I don't believe stage is a best solution for game views. It's more of a UI thing, but for now we're going to use stage, and if we change stuff, then we'll let you know. And obviously you'll feel free to, you know, comment on this and let us know your opinion. So let's create a stage first. We're going to our, again, core, and like create a new class. This one is short, just a game stage. It's going to extend stage. We need a constructor, public game stage. And how about we provide a scene loader to it? So it should get the scene loader and then do whatever it wants with it. So I say game stage. Oh, sorry, let's make it private game stage, and stage equals new game stage, scene loader. I'm going to put all those codes on GitHub, so don't worry. Should be easy for you to download this stuff. And stage act GDX. This is basically a libGDX stuff. You need to call act and pass it the amount of time passed since the last call. And then you should call a draw function, so it will draw the stuff. And this little bit will just, you know, clear your stage to black color. And if we draw it right now, we have again black screen, but with a stage. Now we have scene loader, we have stage. It's totally the time to render this thing, and now it's going to be easy. We're just going to add actor to the stage, which is scene loader, scene actor, which is the root actor. This is root of everything on your scene. And ta-da! We have everything rendered, looking good. Now this basically covers everything you need to know about the asset management, but let's just mess around and make this a playable something. For that, I want to show you, if we want to move this ship around, then we need to get it with our code, and for that it needs to have an identifier. This ship has an identifier, it's called ship. You can make it through your editor. And then we have this cloud, which is cloud1. So here's what I'm going to do. I'm going to say scene loader, scene actor, get item by ID ship. That's simple. Our ship is a sprite animation, right? And private. Oops. And ship equals this, and as this needs to be casted. And let's override our public void oct function which comes with stage. This is called every frame, and like if GDX, we wanna move ship left or right when the A or D key is pressed, for example. We say GDX input is key pressed. Wow, just pressed the key code. Nice. I haven't seen this one, but we need key pressed and keys A, else if else, and here goes the BK. Oh, sorry, DK. D. And this should move ship left, and this one should move it right. So shape set x, ship get x minus 200 delta, and I know it's 200 because I've done that before today 2 times. Don't remind me about it. Okay. Ship pause. We don't want it to move his legs at first, and we don't move it. We want it to stop moving legs when you don't press anything. But when the buttons to move are pressed, we want it to resume the animation. Besides that, let's just run it. And ooh, yeah. Okay, almost there. It doesn't move though, doesn't animate. Resume, pause. Okay. Huh? That is strange. This should have worked. Will this work? Nope. Let me figure this out. Yep, right, my bad. Obviously we called an act and we didn't call super act, which is important because that's what does things, right? And yep, now it's more alive. How about we turn it back like this? Set scale x minus 1 and set scale x 1 and run it again, and ooh, oh, you see this little jump? It's because it rotates and scales around its origin point, and the origin point is not by default in the center, so we put it in the center by doing set origin x shape get width half, and now it's perfect. Yay, it looks beautiful. And we can make clouds follow by saying private composite item. Actually, let me show you that. You see the clouds are a complicated object. It's a mix of image and particle effect, so it's a composite item, and it has a name. It's cloud1. So it's going to be a composite item cloud, and cloud equals scene loader scene actor get composite item by ID cloud1. And how about cloud set x ship get x, and that's it. And it follows. This is a set day for little ship. There is a little bit of offset, but I don't think we care as much as it requires to fix it. So poor ship. Now you can edit this thing really quick. For example, if I just swap the house, put it here and trees here, and I don't know, maybe this crazy ninja here, and save this, and then press Ctrl E, which will export. Ctrl E, done. The assets are going to be refreshed here, as well as main scene data file. And if I run it right now, and we will have this replaced and our ninja here, and everything working as planned. So this is a perfect example of how your code is separated from your visuals. So logic is here and visuals are there. I guess that is all I wanted to show you, and Don't forget to go to our website. You can comment on this video, or you can read documentation if you have any questions, or contact me here. Here's my email, or any other email you will see on the contact page. I will also try to make sure we have a Twitter link here ready so you guys can follow for new updates. And I hope this really helped you getting started with Overlap2D LibGDX Runtime. And good luck and happy coding, everyone.